Good morning, everybody. My name is Ward Abdelkader. I am assistant teacher at Ibn Khaldun University in Algeria. It's my pleasure to participate in this conference. In this presentation, I will share with you a part of my research entitled Moving Database Cost Model from Darkness to Light. So the outline of my presentation is given as: first, introduction; second, context and motivation; then our solution; and finally we will end by conclusion and some remarks. Let me start with some general information about the database lifecycle. As you know, the database lifecycle is a process that begins from requirement, conceptual design, logical design, and physical design. These phases are based on metrics and rules to quantify the quality of each solution to optimize the performance metrics. At the level of physical design, the database administrator actor face many challenges of the kind of what is the deployment platform to choose, what's physical structure to choose, how to tune and control the database system, and so on. Usually, these problems are driven by database cost model in the physical design phases. So, what is database cost models? The cost model is a mathematical function assigned for each operation and parameters and matrix values. Operation is a relation algebra operator like join, scan, sort. Each operation depends on algorithm implementation, programmation paradigms like MapReduce, and emerging hardware like new storage device and processing device. The parameters depend on database lifecycle, conceptual, logical, physical, and deployment. A set metrics quantify one non-functional requirement like IO cost or CPU cost. Let's consider the following example that illustrates a cost model calculates a response time of join operation in SSD hard disk. The parameters of this cost model are mapped of layer database system as shown in this figure. Now, where can we find cost model? We realized that the present cost model in the literature is huge, sometimes well explained, otherwise drowned in the discussion of paper. The parameters and the formulas here is drowned in the text. Actually, if you need to survey database cost model domain without considering posteriori our solution, you must collect scientific information, manage the information collected, watch, monitor, and keep regularly informed by the new information. So the scientific researcher face challenges such as: what is the cost model are more appropriate for given context? How did the database cost model evolve in the physical design phases through time? How can classify a cost model per topic, per years, and looking how can be related? So the challenges here, we need a survey of database cost model evolution. In the actual process to search cost model, researcher must use the service index like DBLP and Google Scholar. When we browse it Google Scholar using the keyword database query cost model between 1970 and 2018, we found around 33,800 results corresponding to cost models. The explosion of cost model is mainly due to the spectacular evolution of database technology, which covered the database model from relational to graph, platform, database, systems, processing device, etc. This situation complicates the exploitation, reproduction, and the reuse of existing cost model to provide the reader a good review of the topic, because it's difficult to see how cost models are related from the scientific papers. As a consequence, cost models become an obscure entity. Hence, the problem statement is research question: how to increase the survey papers of cost models related to the evolution of database physical design domain. From this, we can identify these problems. Variety of database cost models, revealed information is drowned in the scientific paper. Usually, authors express the revision and the evolution of cost model using natural text notation. Searching how cost model is adapted is manually costly and consuming process. The case of digital library like DBLP and Google Scholar helps in scientific papers by providing information about other papers, committees and topic. But for instance, one can only consult a cost model in order to see chart, its signature and its component. He needs to find the respective scientific papers, selection and compare them manually. For monitoring survey cost evolution, there is no tool of database cost model survey to accurate the big picture and the mental image of relationship between cost models. This motivates our investigation to assist the survey of evolution of database cost model domain. Our objective, as illustrated, we aim to move the database cost model to light, from darkness to light, to see how cost model entities are related. Our goal is to provide a comprehensive survey process of database cost model. This is important because orienting user to use easily survey cost model, helping researchers to compare and analyze their own cost model, decrease the difficulty related to the constant evolution of database cost model domain. To solve the problem, we have proposed an approach of 4 sequencing phases. First, raw data, scientific file papers are collected. Second, data processing, categorizing cost model changes and analyzing the relation between them. After graph database, the data is stored as a graph model to the cost model evolution, and analytics side, the data is accessible to reporters as a network visualization. We have reviewed the scientific papers and state their contribution, examining the assumption of different database cost models. To study the changes, we need different versions of cost model. We summarize the categories of changes that push the researchers to revisit the cost model defined in the past. In our analysis, we consider the following categories of change: calibrate, or more expressive cost model; extended existing cost model by integrating a new dimension like energy; revisited the cost model and building them from scratch; and cite or use existing cost models in several physical design applications. For example, the authors here in this paper look the cost model proposed by Moneygold in the past and extended it to integrate a new SSD requirement and define a cost model that captures the interaction between the two physical structure index and data partitioning in order to estimate IU cost. To take easy the analysis of cost model relationship, we have proposed a graph model from the cost model evolution that match the need of scientific researcher. This graph model and store the relationship. The cost model survey, the graph data models consist of 5 node types: cost model nodes, scientific research node, context node, author node, and the conference nodes. 2 cost models are linked by 6 relationship types: cited, extended, used, revisited, and calibrated. We look at the cost model survey as a directed graph with a set of nodes and a set of relationship. In our graph model, cost models are represented by node, which label cost model. For each cost model node, we store the information parameters and the paper reference. For cost model, a researcher manifest is defined as a partial set of cost model to formulate a different research question. A researcher needs to answer several questions to get value from data and as relationships. Our proposal has implementing using Neo4j, and we used a query language cipher to explore the content